Hey everybody, today I have another AP Calculus video. This one's from the 2018 exam. We're looking at question 5, part D. This is a very interesting one. It says, let f be the function defined by f of x equals e to the x times cosine of x. And then let g be a differentiable function such that g of pi over 2 is equal to 0. They want us to find the value of the limit as x approaches pi over 2 of the quotient of f and g. There's kind of a lot going on here. They also give us the graph of g prime, which you can see it starts down here at around, I don't know, 0 comma 1 half, negative 1 half, and then it climbs up to pi over 2 comma 2, and then it goes straight down to around around like 2 pi comma negative 1 half, something like that. The numbers aren't totally necessary. I think the only important thing here is that it reaches this pi over 2 comma 2. The reason why you can kind of tell it's important is because pi over 2 is what we're dealing with here. They have two mentions of pi over 2, so it's kind of a relevant thing. So let's see what we can do to try to figure things out. So we can start by trying to directly evaluate this and see where that takes us. So let me first write it out here. So we have the limit as x approaches pi over 2 of f of x over g of x. We can use limit properties to help us break this up. So the limit of a quotient is equal to the quotient of the limits. So let me just write that out. So we can have the limit as x approaches pi over 2 of f of x, and then the limit as x approaches pi over 2 of g of x. So notice that I turned this from the limit of the quotient to the quotient of the limits. So this isn't totally necessary for you to think about, but this is what's happening, and then you can from here, evaluate each one directly. So we can start with f of x. So if we want to plug in pi over 2 to f of x, so let me just write here that f of x, or f of pi over 2 is what we're looking at specifically. That's going to be e to the pi over 2 times cosine of pi over 2. Thing is, cosine of pi over 2 is 0, and that means that this whole thing is 0. So we have 0 on the top. Now the limit as x approaches pi over 2 of g of x, well, g is differentiable. That means it's continuous, and so g of pi over 2 is equal to the limit as x approaches pi over 2 of g of x. So that means that this is equal to g of pi over 2, and that's 0. So this is also 0. One quick thing I forgot to mention, we know that the limit as x approaches pi over 2 of f of x is equal to f of pi over 2 because it's also continuous. E to the x times cosine of x is a continuous function, and you can kind of determine that by knowing that e to the x is continuous, cosine of x is continuous, and a combination of continuous functions will give you a continuous function. I can make a separate video for that, but that's kind of an interesting thing you can do with continuity and limit properties and all that. So because this is continuous, then it's okay to just plug in the value at pi over 2. So there we go. So we got 0 over 0, which warrants a L'Hopital's rule sort of situation. So let me just write here, we're going to use L'Hopital's rule. And essentially, let's make sure we can actually do this. So it tells us directly that g is differentiable, so that's fine. We can take the derivative. Can we do that for f? Well, yes, because e to the x is differentiable, cosine of x is differentiable, and again, that means we can take the derivative, because then a combination of differentiable functions will be differentiable. We don't necessarily need properties to see that. We can just try to take the derivative of this, and then notice that, oh yeah, we can do that. And then we can actually do that. We can actually just evaluate it because we'll probably need the value anyway. So let's do this. So if we want f prime of x, first I'll just do f prime of x. We can start by saying this is going to be, so e to the x times the derivative of cosine is going to be negative sine of x. So I'm just going to put the negative here, and then plus, now the derivative of e to the x is just e to the x, and then multiplied by cosine of x, and there we go. So now f prime of pi over 2 is going to be, well, we just plug in pi over 2 into here. So let's see if we can see any shortcuts. So we know cosine of x, cosine of pi over 2, well, we said that was 0. So this whole term is 0, so I can just, that we can get rid of that. We don't need it. So, and then over here, sine of pi over 2, that's going to be 1. And so if we just know that this is 1, then that means that our answer is just negative e to the x. It's just this part. And so f prime of pi over 2 is negative e to the pi over 2. That's what I meant to put there. So negative e to the pi over 2. And so that means, obviously, if we found a derivative, that means it is differentiable at that point. And that will be useful in a second. So if we're trying to compute L'Hopital's rule, then that tells us that this is going to be equal to the limit as x approaches pi over 2 of f prime of x over g prime of x. And again, I could just turn this into the quotient like I did here. It's not totally necessary, we can just skip that. So f prime, we just found to be negative e to the pi over 2. And then g prime of x, well, they gave us the graph. They wouldn't give us a graph if they didn't want us to use it. So let's actually use this now. We're looking for the derivative of g at pi over 2. Notice this is g prime here. So don't find the slope because this is already g prime. We're just going to find the exact point. And if we're looking at pi over 2, well, that's going to give us 2. So that's kind of what I said earlier. It's probably going to be useful in a second. So yeah, so this is going to be 2 here. Oops, let me write that a little better. And so that tells us that the limit as x approaches pi over 2 of f of x over g of x is equal to negative e to the pi over 2 all divided by 2. So whatever way you want to write it, that's like negative 1/2 e to the pi over 2. However you want to do it, doesn't matter. But yeah, that's how you'd find it. And hopefully my explanation made sense. I can kind of clear up the continuity and differentiability sort of stuff that I talked about earlier today. I can do that in a separate video. But yeah, if you have any questions, let me know, and I will see you guys later. Bye, guys!